Okay, this is the third video, so it's going to be even quicker. This is a little bit of an easier function anyway. So when we simplify this, there's nothing we can do in the top, just x plus 2. We can factor out a 2 from the denominator, so we get an x plus 3. So this is the simplified version. Nothing cancels. So let's find our domain. We care about when the denominator is equal to 0. That's only going to occur when x plus 3 is equal to 0. So x is equal to negative 3. All right, so our domain is going to be all real numbers except for negative 3. That's 1, 2, 3. So since nothing cancels out here, it means that this is going to be a vertical asymptote. Since no factors canceled out, we have no holes. And our simplified version is x plus 2 over 2 x plus 3. All right, so let me get that vertical asymptote in. All right, so next thing we could do, let's find the x-intercepts. We find the x-intercepts when the numerator is equal to 0. So when x plus 2 is equal to 0, x plus 2 is equal to 0 when x is equal to negative 2. That means that negative 2 is going to be our x-intercept. All right, so here we have one where the y-intercept finally is not the origin. So to find the y-intercept, there's two ways we could do it. The first way is just plug in 0 for x. So we're going to get 0 plus 2 over 2, 0 plus 3. We're going to get 2 over 2 times 3, which is 6 or 1/3. So 0, 1/3, maybe right around there-ish, is going to be our y-intercept. And then another way that you can do it is you can look at your original function and just take and just divide the constants. So 2 divided by 6 is the exact same thing that we got there. Just a little bit of a quicker way to do it. All right, cool. So 0, 1/3 is our x-intercepts. When we look at the function, either the original or the simplified version, the degree of the top, the x plus 2, is degree 1. The 2x plus 6, or the 2 times x plus 3, whichever way you want to look at it, is also degree 1. So the degrees are the same. So when that happens, it's going to be the ratio of the leading coefficients. It's going to be this 1 divided by 2. Alternatively, if you look at the numerator, the only thing that lives on in the numerator is the x when x gets super, super large. The only thing that lives on in the denominator is 2x. Cancel, and we're left with 1/2. So 1/2 is going to be our y-intercept. I'm sorry, our horizontal asymptote. So something right around here-ish. It's just going to be a little bit above our, wow, that is not even close to being straight. You're going to have to use your imagination for this one. So now we could be a little sneaky here. Something that I mentioned, I think, on the previous slide and I didn't even talk about. So we know, and I'm going to do a table of signs in a second, we know that the function has to look like this. And we know that the function has to look like this. Oh, it just has to hit that point and get really, really close. And so let me quickly explain why that's the case. So on this interval, it has to look like this because there's no x-intercepts. Right? There's never a time between negative infinity and negative 3 where the function hits the x-axis. So it could never go and do anything like that. So it always has to be kind of like in this little kind of part in here. Right? So it has to look like that. Now, granted, we could have a function that would kind of like come down, maybe hit and turn, right? But well, there's a reason it's not going to do that, and it deals with something called multiplicity. If you have questions on multiplicity, talk to me in office hours. It's a really easy way to graph these things. So if we make a table of signs, we have a asymptote at negative 3. We have a 0 at negative 2. So if we pick some value less than negative 3, we plug it into this simplified version. Remember the x plus 2, 2x plus 3, which we really only care in this, let me find a spot, x plus 2 over 2, x plus 3. We really just care about like the factors, right? We don't care about this 2. This 2 doesn't do anything. It's positive. It's never going to change anything. So if I plug in like negative 4, so if x is negative 4 plus 2 is negative. Negative 4 plus 3 is also negative, so our function is going to be positive, like we have right here. Between negative 3 and negative 2, if I pick some number like negative 2.5, negative 2.5 plus 2 is negative, negative 2.5 plus 3 is positive, so it's going to be negative, which is what we have right here from here to there. And then if we pick some value bigger than negative 2, which we don't have to do because we already plugged in 0, but if you do pick some other number, if you pick, say, I don't know, 1 plus 2 is positive, 1 plus 3 is also positive, so we're going to get a positive function, which is from kind of like here. Whoa, I still can't draw straight lines. From there on. 5 minutes close. I was close with this, and I'm going to try to get the next one down to 5 minutes, promise.